to solve integral, there are few things that you absolutely need to know. Okay. I can have these x, y, and z axis. And do you know equation of this plane, which is the xy plane?
Yeah.
What is that?
So the formula?
The formula of this plane, this one, is z equal to 0.
I don't know.
Oh, okay. Well, so now now we have like 3 axes, x, y, and z, right? Now I'm talking about this plane. Can you imagine the 3D plane over here, this one?
Yeah.
And this is called as a principal plane. It is called as principal plane. Please respond.
Yeah.
And the principal plane, now this one has got an equation z equals 0.
Okay.
Right? Can you tell me why? Because on xy plane, the value of z is going to be 0.
I don't know why.
Well, because okay, when you have x and y, tell me now this is 2D. On a contrary, this is 3D, right?
Yeah.
Now tell me, when you have x-axis, all these points have got y coordinate 0, right?
Yeah.
So the same way, on x-axis, y is 0. That way, if it is xy plane, the z is 0. That makes sense, is it?
Okay. I got it.
Got it?
Yeah.
Okay. So now going back, tell me about this one. That what do you think is the equation of this plane?
Y equals 0.
Perfect. Tell me the equation of this plane.
X equals 0.
These are all called as principal planes. Okay. That's the first learning that we have here. Okay. I'm sure you know this, but it's just my job to like make sure that you know these things very well. This is x-axis and this is y-axis. Okay, do you know equation of this line? This line here, x-axis?
Yeah, it's y equals 0.
Perfect. And of course, the equation of this line is going to be x equals 0.
Yeah.
Okay. If I have a line parallel to y-axis like this, and say this length is a, do you know the equation of this line?
X equals y.
X equals a.
A.
Right? I hope you get that point as well.
Okay.
Tell me equation of this line. This is x, this is y. What is the equation of this line at a 45 degrees? Y equals x. Do you know this?
Yeah.
You have to immediately stop me if I say something that doesn't make very good sense to you.
Okay.
So, well, now that's your, these are some of the basic equations that I wanted to talk about. Do you know integration of sine x?
Yeah, it's minus cosine x.
Minus cosine x. Okay, so I'm just going to like avoid writing that dx and c. We're just going to keep it very straightforward. This is just for your understanding though, minus cos x. The dx is there and plus c is there. Okay, so we will just like dilute things down a little bit. Do you know integration of sine of ax plus b?
Yeah, it's minus cosine x, ax plus b, and a.
Over a, right? Okay, tell me what is the integration of, okay, now this is good enough. I'm sure you understand this also. Tell me about ax plus b the whole cube. What is the integral of this?
I don't know that one.
Oh, well, ax plus b raised to 4.
Oh, yeah, over 4.
And then there is a.
Oh.
Now the next thing that I want you to know, hey, do you know integration of uv dx? Or just uv? Now that we're not writing dx. What is the integral uv? Do you know the product rule of integration?
No.
U integral v minus integral, tell me.
V? No, I don't know that one.
Okay, du by dv, du over dv integral.
Oh, I remember. Yeah.
The whole dx. Right? Okay. Now I want to take one example. You really tell me see, look, I'm trying to now figure out where are you right now. Okay. So that I get an idea what things you know and what you don't. So accordingly, I will teach you your problems.
Okay.
So this is just a quick basics. We will wrap up and immediately start solving questions. Okay. The method of teaching is going to be through solving questions. So I will pick up one question from your form from the question sheet that you gave me. Okay. And while teaching you that question, I'll explain to you the basics as well.
Okay.
Tell me about this one. I want to find out integration of ln x dx. Tell me how I'll do this.
It's 1 over x.
Oh, no. The integral.
Oh, integral. ln x square?
Nope. There is this formula you got to know.
Oh, it's.
Do you know LIATE?
No. Oh, yeah, I know. Logarithm?
Yes.
Yeah.
Inverse, algebraic, trigonometric, and exponential.
Yeah.
Can you repeat? L. Logarithm.
Logarithmic?
I.
Inverse?
Inverse.
What?
Algebraic.
Algebraic, trigonometric, and
Exponential.
explanation.
Yeah. That has to be the sequence, right?
Yeah.
So now what do? Is we write this as ln x times 1. Is there a 1 by default everywhere?
Yeah.
Dx. All right.
Mm-hmm.
Now tell me, logarithmic comes first or algebraic comes first? This is algebraic, right?
Logarithmic.
And this is logarithmic, right? So this has to be u and this has to be v.
Mm-hmm.
So now we are using this formula that I gave you with the hashtag. Can you help me with the solution now?
ln x integral
ln x
1.
Integral 1.
Tell
me. Then
yeah. It's 1 over x.
du over dx. That is 1 over perfect.
Over 1.
Integral 1 dx.
Yeah.
The whole dx. Do you know what is integral 1 dx?
It's x.
And then this x and this x will cancel out?
Yeah.
Okay. Tell me, ln x times x. That's integral of 1.
Yeah.
Minus integral
X. 1.
1 dx. So that's just x again.
Yeah.
So you get x ln x minus x. So I can simply take x out and this is ln x minus 1. This is the very basic integral, right?
Mm-hmm.
Okay. So now the next what I want to ask you is, tell me about this one. Do you know there is one more simplified version of the same formula that I gave you just now? Like this formula can be also written in this way. Okay, I'll tell you how. Integral uv can be written as u v1 minus u prime v2 plus u double prime v3 minus dot 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 so on and so forth. Now let me explain better. Supposing if you have integral of x squared sine x, you can write this as, okay, this is u and this is v. And this is a completely different formula. Just bear with me for a minute. Can you use the formula for me? We have to do this.
Okay.
It remains as it is. So what is u? X squared?
X squared.
As it is. Okay, I'll tell you what is v1. V1 is the first integral of v.
Cosine
x. Sine is going to be minus cosine x.
Yeah.
Okay, keep going. Minus u prime, you can guess it, right? U prime has to be differentiation of this.
2x.
2x.
Sine x.
Oh, well, you have to integrate this whole thing.
Yeah, sine x.
Integral of cosine x is sine x. Minus will remain, right? You see what I'm saying?
Yeah.
Integral of cosine x is just sine x.
But the negative one, it will be negative.
And the negative just carries on, right?
Okay.
Okay. Tell me the next one. Plus, this plus.
2.
That's 2. And again, v3 is going to be the second integral.
Cosine.
Now the integration of this, right? That's going to be what? Cosine?
Cosine.
Cosine x. Do you see pose that it's all 0? Why? Because the derivative of 2 is going to be 0.
Yeah.
And then it's just going to be 0. Okay.
Yeah.
So now I want you to just remember this formula comes very extremely handy when we solve some good questions. Okay. Okay.
Okay.
When let me write down a note here. Note, when U is such that its higher differentiation becomes 0, use above formula. Tell me, when will you use formula like this? When you have something like U, which is x squared, if you keep differentiating, the first derivative is 2x, the next derivative is 2, and the next derivative is 0, and everything else is 0 after that, right?
Yeah.
When this happens, you do this formula.
Okay.
Okay, read the note, can you?
When U is such that its higher
Differentiation,
differentiation becomes 0, use that formula.
use the above formula, right? Achha, will you use formula over here? Will you use the same formula here? No.
No, we don't need.
Here it won't work because your U is not going to become 0 ever.
Okay.
Even if you differentiate 100 times. So here you won't use this formula. So we have two versions of integral UV.
Okay.
Can you quickly revise, like read them for me? The first and the second formula, please. This one.
It's U V integral.
Yeah.
U integral V minus integral du over dv integral V dx.
For dx, right? Okay. The other.
And that one is integral uv u v1 minus
You remember
u.
that the first term remains as it is in the first time. You see, x square remains.
Yeah.
And then v1. v1 is the first integral of v.
Okay.
So the integral of sine became my negative cosine x. And v2 is the second integral. So you already have v1. You integrate this again and you get this.
Okay.
Is it understood very well?
Yeah.
We will be using this formula a lot. Okay, they make our life easy. Anyways, so that's another thing that I wanted to discuss. And before we go ahead with the next one, I just want you to remember two more formula actually. I'm sure you know this. Do you know f prime of x over f of x?
Yeah.
Do you know what that is?
I don't remember.
Ln f of x. Just remember this.
Okay.
Okay. Now let me give you an example for this. Now these are the examples. Okay. So there is formula, example, the formula and the example. Now the formula and the example. Okay. So now the example is, let's say cosine x over sine x dx. Can you tell me the answer now?
It's ln cosine x.
Do you know this is f?
Oh, ln sine x.
And this is f prime. So can you imagine the answer has to be?
It's ln.
Yes.
F sine x.
Perfect.
Okay.
That's it. Moving on. One more formula. This is the most amazing formula. I don't know if you use it, but then I don't know if it's given in your book or not, but then trust me, this is going to just
no, we didn't learn any of this.
Okay. So now I'm giving you one more formula. I'm just going to write it down in the simplest form. If you have a function of power n, and if you have the derivative of that function f prime, okay, the answer is simply f to the n plus 1 over n plus 1. This will make your life easy. This is okay. And I'm going to give you an example that so you understand better. Integral. Supposing if I give you sine x to the 9, and if I give you cos x dx, what is the integral answer of this integral going to be?
It's sine x to the 10.
Perfect. This is f. This is n.
Over 10.
And this is f prime. Is it correct?
Yeah.
Tell me how that be. This is
it's sine x over 10 over 10. To the 10 over 10.
Correct?
Yeah.
Let's begin with the first question. Now, while we solve this question, I'll explain also how things work. This is integral. Can you read that out for me? 0 to 3. Can you please read that out for me?
I don't have it right now.
4x minus 3 squared sin y dy dx.
Dy dx. Yeah.
So I'm just going to like quickly write down a few points here. Okay. The first point is just remember this. Okay. This will just help you a lot. Always evaluate inner integrals first. Can you repeat that?
Always evaluate. What is that? Inward?
Inner integral, the inside integral.
Inside integral. Okay.
Yes, the inner integral first. So what we're gonna do is, and when I say dy, okay, this is my inner integral with respect to y. So these are the limits of y, and these are limits of x. Okay. Next point is, while evaluating one variable, all others are treated as constants.
Oh yeah. I know that.
Okay, so right now when you want to solve this, okay, it's a good practice to write down the integral as I. So let me write down this integral as I. Okay, we'll evaluate the inner integral first. Okay, so now this I is going to be integral x going from 0 to 3. Okay, now this is the integral of x, right? So I can write it like this: 4x minus 3, the whole square, separate. Now integral y equals 0 to pi over 3. This is sine y. This is dy and this is dx. Okay. Actually, yeah.
Can we do that way for all double integrals?
Yes.
Okay.
You can assume it for now. You can assume that safely. No problem.
Okay.
Yeah. So okay, let's integrate this. How will you integrate the first one?
Is the formula that you show?
Yes. X plus b to the n is going to be x plus b to the n plus 1 over n plus 1 times a. Tell me now.
It's 4x minus 3 to the 3 over 3.
Times 4. Don't forget.
Times 4.
And the limits will go from?
0 to 3.
And integral of sine is going to be?
Cosine y.
Cosine
minus
y.
Cosine y.
Cosine y. Okay. And that will go from y
0 to pi 3.
Pi over. So I get I equals, okay, let's put the upper limit now. First we put upper limit, right?
Yeah.
What is that?
12.
Yes, 12 minus 3.
To the 3.
12 minus 3 to the 3. The base remains
12.
12. That's the upper, right? So that's u for upper. Okay? U for upper. Minus, when you put x 0?
It's 0 over 12.
Minus 3 cube over 12.
Yeah.
That's the lower, right? That's the first integral. How about the second one? I'll take the minus out, the minus the cos y out. And then this is cos pi over 3.
Pi over 3.
Minus cos 0. You know,
0.
cos 0 is 1.
Yeah.
What is cos pi over 3?
Pi over 1 over 2.
1 over 2, that's correct. So then I is going to be, what is going to be this integral?
9 to the 3 over 12.
3 over 12 minus, that becomes plus, right?
Yeah.
Negative, that's going to be
3 to the 3.
3 is 27. 27 over 12. Then there is a minus sign here. That's half minus 1. Okay. So now I'll continue here. Tell me. I equals
9 to the 3. What is that?
9 to the 3 plus 27.
Minus 1 over 2.
That's not like that's a product, okay?
Okay.
Yeah. So that's 1 over half minus 1 is going to be negative half. That makes it plus half. I
Yeah.
equals 24 and 9 cube. What is that number? Maybe Google it.
I don't remember.
Okay, so I think we can always get the answer. Do you have the answer? I think we have the answer.
Yeah. It's 63 over 2.
I'm 100% sure that you will get it right. So I is going to be 63 over 2.
Okay.
Okay. So do the math, do the number crunching, and you'll get the answer.
Okay.
Fair enough?
Mhm.
Okay. So I'm saving the first question. Have you followed this?
Yeah.
Let's go to the next one then.
Yeah.
Because I see the integral.
I did wrong. I
Sorry?
don't know. I tried, but I did wrong.
Okay, so now you say I write, okay? It's you,
Okay.
not me. It's just like I'll write on whatever you say.
Okay.
1 to 2 integral 0 to
Pi over 2.
pi over 2
X cosine x over y.
y
Dx dy.
dx dy. So now let's just assume this as I and we solve this, okay?
Okay.
So, well, do you
Then
see,
write.
dx dy right now?
Yeah.
So the dx simply means the limits of x are these.
Yeah.
And dy outside means limits of y are these.
Yeah.
Okay, so now let's just separate them and write down.
1 to 2
Yes.
to 1 over y.
1 over y dy
Y.
x
0 to pi over 2
pi over 2.
x cosine x dy dx.
Hey, do you see? Okay, tell me how now. 1 over y, do you know the integral of 1 over y?
It's not ln y.
I think it is ln y.
Is it ln y? Yeah. Okay. Yeah.
So integral 1 over x is ln x.
Okay.
For your reference over here. Okay. So you have this as ln y.
So
Y
it's
will
ln
that will go
1, 2, 3.
Okay, now what do you do to this one?
X square over 2.
Nope.
Oh, UDV.
Tell me which formula will you use, the first version or the second version?
Second version.
Because your
No.
x is u, you're correct. The
I
x
need prep.
u. No, you're good. When you say x, that is u.
Yeah.
And if you differentiate x again and again, what that becomes eventually?
It will be 0.
First derivative is 1, the second derivative is 0, third derivative is 0. All of them are 0, right? After that.
Yeah.
And when that happens, you use my second formula, okay? And not the first one.
Okay.
And because second formula is much easier, you know.
Yeah.
You remember the formula.
I don't.
Okay. So I'll tell you that formula once again. Look, integral. Tell me, integral uv is going to be u for the first term as it is. The integral of v is v1.
Oh, and y v1.
Tell me.
Yeah. Plus
Now that's the next is negative.
u.
Prime.
Yeah, and v2.
V2.
Plus u2. Yeah, and v3. And it's going on. Okay.
Work that formula here.
Okay.
X integral of cosine x is just sine x.
Yeah.
Minus
1.
1. Integral of sine x is
Minus cosine x.
minus cosine x.
Plus 0.
End of it, right?
Mm-hmm.
Go from 0 to pi over 2.
Yeah.
And there is a product here, don't forget. Tell me, I is going to be
ln2 minus ln1.
ln1 is 0.
Yeah.
Then put upper
Okay.
limit.
Pi over 2. Sine pi over 2. 1. Yeah. Minus 1. Oh, yeah. Cosine pi over 2, 0. Yeah. Okay.
Upper, tell me lower limit.
It's 0. Oh, yeah.
Right?
Uh-huh.
That's the lower limit. So now what happens? Let's write down the final answer. This is I equals ln 2
ln 2
times.
pi over 2 minus 1.
Perfect. Are we correct with the answer?
Haha. Pi over 2. Yeah, that's correct.
Yep. This is like cross multiplied.
But it says pi minus 1. Minus 2. The
That's
answer.
correct. I equals ln 2 times, just cross multiply.
Oh, yeah.
I minus 2 over 2.
Haha. Okay, I got it.
I minus 2 ln 2 over 2.
Okay.
That's the final answer. Okay, so now we have some good questions starting. Okay.
Okay.
Okay, so now do you see the question number 3? There is a huge difference between question number 2 and question number 3, because question number 3, these limits are not given.
Okay.
So you don't have the limits ready made.
Uh-huh.
You have to figure out from the region R.
Okay.
I will explain how that works. But as of now, this is a very different question than the previous question.
Okay.
Okay. Now they said R, the value of R is 1 to 2 cross 0 to 1. Okay. First of all, first point is, do you understand dA is dx dy
Or dy dx.
or dy dx? Okay, let's write that right up. Or dy dx. We just have to write down this integral I, this one, as integral x goes from 1 to 2, integral y goes from 0 to 1 over x plus y dA.
Okay.
Okay, now let us integrate this. Oh, sorry. We should write dA as dy dx. Okay, you can write dy by dx, dy dx, or dx dy. It's completely up to you. It's not going to make any difference.
Okay.
Okay, so now I hope we get the answer right with that. That's my approach. We'll first integrate the inner integral that I already told you.
Inner integral.
The inside integral,
It's y.
it's integral of y, right? So I took this dy. Okay.
Okay.
Now just remember while integrating with respect to y, treat x constant. Can you remember that? While integrating with respect to y, treat x constant. So your x is a constant, right?
Yeah.
So now what is the integral of 1 over y?
ln y.
Ln y. So what is 1 over y plus a? Ln y plus a.
ln y.
Is that correct?
It's ln y.
Ln y plus
Oh,
a.
yeah. Yeah, yeah.
Did you get that?
Yeah, I got it.
So do you understand that x is like a constant? So what is the integral of this going to be?
ln x plus y.
Perfect. So let's write that. I is going to be ln x equals 1 over 2. This is ln x plus y, and that will go from 0 to 1 dx. I equals integral x equals 1 to 2. Put upper limit and lower limit.
Ln x plus 1.
Please remember these are the limits of y.
Plus 1.
X plus 1
minus ln x plus 0.
X.
Uh-huh.
Now we have to integrate this, right?
Uh-huh. Yeah.
We already actually, we have just like some time back, we have done this integral ln. Do you remember?
Yeah.
We just did ln x. The integral, it was x ln x minus 1.
Yeah.
So
That one will be x plus 1 to
no,
the ln.
no, I think we have to solve and see.
So we'll see.
This, we have to solve and see how it works out.
Uh-huh.
Okay, so as of now, this answer we already have. Now tell me how will you do ln x plus 1, the integral?
X plus 1.
Yes. This is 1, right?
Uh-huh.
You remember the first formula will come into action now?
So it's 1.
U times V.
Uh-huh.
You remember the formula?
Oh, yeah. It's u v1 minus.
No, not that one.
Not that one.
Because now you're doing integral uv, where your u is not becoming 0, right?
Oh, yeah. It's first formula.
Correct. Tell me which one. How is that? U integral v minus integral du over dv integral v dx the whole dx.
That's hard.
Not really. You just have to remember it maybe later on.
Okay.
Give some time and you'll be fine.
Okay.
Yeah. U
U, it's L x
log
plus ln x plus 1.
integral
Oh,
dx
yeah. 1
and
dx. Minus
then
integral du.
1 over x plus 1
Uh-huh.
du
Integral
integral
dx.
1 dx the whole dx.
Yeah.
Tell me, ln x plus 1 times x
Minus
integral.
1
That's
over x plus 1.
how will that be? X ln x plus 1
Mm-hmm.
minus integral. Do you know how to solve this? You can do plus 1 and minus 1
Why?
because that's an adjustment. Works wonderfully. Wonderfully well.
Okay.
I added 1 and separated 1. Is that allowed? The red part?
Uh-huh.
Is that allowed? Yes or no?
Yes.
So now I can break it up, right? Do you
Uh-huh.
know a plus b over c can be written as a over c plus b over c?
Yes.
So do the same thing here. This is your a, this is b, this is c. Can we break them?
Mm-hmm.
Tell me,
It's
x plus 1 over x plus 1 minus 1 over x plus 1
1
dx x ln x plus 1 minus integral 1 minus 1 over x plus 1 dx. Am I making sense so far?
Uh-huh.
Tell me now. You stop me, okay? I trust you that you will stop me when you don't get something.
Okay.
All right. So this is x ln x plus 1. Tell me. Minus. Okay. What is the integral of x? 1 is x.
Mm-hmm.
Minus ln x plus 1.
Yeah.
Integral of this is going to be ln x plus 1, right?
Yeah.
Okay. So we got the answer.
Mm-hmm.
So can we like simplify? Like I can club these two.
Mm-hmm.
Tell me what I get. Uh, if I take ln x plus 1 out, this is x minus 1. Does that make sense?
Yes.
Minus this x over here.
Uh-huh.
So now that's the integral part, okay? So I have solved the integral of this. I already have this. So let us write down the answer of integral. Tell me, what will I get? I equals, tell me, I
It's ln
that's ln
ln
x plus 1 times
x minus 1
minus x minus
1
integral of this one
ln x
over here.
x ln x minus 1.
Let's just multiply this whole thing. X
Okay.
ln x minus x. That will go from 1 to 2. But then, do you see there was a bracket here?
Yes.
This one. I do a lot of silly mistakes, so you have to be very careful, okay?
Okay.
I count on you completely. So
Okay.
if I make a mistake, you are responsible.
Okay.
Just kidding. So anyway, so this is x cancels out. So that's about it, I guess. So let us start solving. I equals, tell me upper limit.
ln 2
ln 3.
plus 1. 2 minus 1, it's 1.
1 minute. You put 2 here, right?
Yeah, I got it.
Then 3 is correct.
3.
Then 3 times 1, this thing.
1, yeah.
Minus 1. Minus
It's
2 ln 2. Is that correct?
Yes.
Tell me lower.
It's ln 2.
0. Yes or no?
Yes.
Tell me
But
next.
why we didn't write the ln for
Yeah, but
first?
that's a 0, right? This is 0, right?
Oh, yeah.
Everything is 0. Okay, tell me 0.
0 minus 1 ln 1.
You know ln 1 is 0?
Yeah.
The whole part is 0. So do you know that if you have a ln 2, you can write ln 2 to the power a?
Yes.
So we just do that here. We will do that here.
ln 3 minus ln 2 to the 2.
Yes, so that's going to be I equals ln 3 minus ln 2 to the power 2.
Okay.
So you get I equals
ln 3 minus ln 4. Oh, yeah.
ln 3 or 4. I am
Yeah.
just hoping that we got the right answer. I'm a little bit skeptical, but I think we got the right answer.
Okay.
Question 3, right? This is
Yes.
log 27 over 16. So I leave it for you to figure out what went wrong.
Okay.
Sounds good? So I'll save it. Maybe some solving is wrong or something is wrong. Figure it out. Let's do 4th.
Yeah.
So this time be very careful. We don't want to go wrong all the time. Okay. So find the volume under graph f of x comma y. F of x comma y. Do you understand? It's a function of x and y.
Yes.
And the value is going to be x squared plus y squared over xy. That's your f of x comma y.
Okay.
So above rectangle, R equals 1 to 2 cross 1 to 2. So now let me explain what this question is trying to figure out. What this question wants us to figure out. Okay. So now here is the explanation of this whole situation. First of all, this is say x and this is y. Okay. Before we get to that, tell me if I only say f of x. Look, now I'm teaching you some concept. You have to be very attentive.
Okay.
Instead of f of x comma y, supposing if I give you only f of x, and if I say, hey, it is x squared, do you know how to plot this?
Yeah.
This is x, this is y. and y itself is f of x. Okay. And if I decide to plot this, I'll simply make x and y. When x is 0, y is 0. Because this is y, right?
Yeah.
Okay. So y is this. Tell me when x is 2. Y is 4.
When x is
Right? When
Yeah.
x is 3.
9.
9. So can we plot this? 0, 0, 2, 4. Then 3, 9. These are all the points, right?
Yes.
And we know it's a parabola like this.
Okay.
So now there are a few things that I want you to understand. The example that I gave you over here, okay, is in 2 dimensions.
Okay.
Where typically y is always a function of x. So y depends on x. So we call y as dependent and we call x as independent variable.
Okay.
And when you say, let me write that example also. When I say y is equal to x square, okay, and typically y is a function of x, so I can write this as or f of x is x squared. And supposing if I plot it, I'm just going to get a parabola.
Okay.
And this is a 2D shape because you have x and you have y.
Okay.
Now compare all this to a 3D situation. 3D simply means 3 dimensions, right? Now let me say u is a function of x and y.
Okay.
Now tell me the same story, right? Just do the comparison. We are comparing the 2D part with the 3D part. Tell me, u is dependent and it depends on, is it making sense to you?
Yeah.
It depends on x and y. So x and y are independent. So now what would be the example? Example would be u is x squared plus y squared. I'm just trying to keep it on a similar lines.
Okay.
Now how will you plot it? Tell me. X, y and u. Y and u. X0, Y0. What is u?
0.
X0, Y1. What is u?
1.
1, 0, 1. Tell me one last. X is 2, Y is 2.
4.
8.
4. Oh yeah, square. Got
And
it.
I can keep on doing this, right?
Okay.
Now I want to plot it. How will that be? I have this as X and this as Y. Now you tell me, where is 0, 0?
Origin.
And what is the value of u? Let's say this is u. U is 0, right?
Yeah.
Where is 0, 1? Over here. What is the value of u?
There.
1. Tell me about 1, 0. It's here.
Oh.
What is the value of u?
1.
Tell me the 2 point. Where will that be?
2 to the 2.
Over here. That's x2 and y2, right?
And 8.
How much is u? Very,
8.
very, 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 very big. Yes or no?
Yeah.
So do you understand that if I connect all these points, do you see there will be a surface here? Can you imagine? Look at me. Can you look at me? X and y. Okay? On every x and y, there is a point x comma y, like 2, 2, 1, 1, 3, 3, 4, 4, whatever. So on this plane, do you see there is a height on every point?
Yes.
and then there is a surface that forms out of it.
Yeah.
So when I say f of x comma y, it's actually a surface on top of xy plane.
Okay.
For understanding sake, if you have this as x-axis and this as y-axis, f of x comma y is going to be some surface. This is f of x comma y.
Okay.
On every point, there will be some height. This point, the height is here. You see, this is a surface.
Mhm.
This is f of x comma y. Is the visualization clear in your head?
Yes.
Now, can you read the question?
Find the volume under the graph of fxy
Okay.
above the rectangle.
So what are they trying to tell you? They're saying, the question is saying that f of x comma y is going to be some surface like this. And under this surface, 1 to 2, 1 to 2. These are the range of x and this is the range of y. So a range of x is going to be from 1 to 2.
Okay.
Range of y is also going to be from 1 to 2. And then 1 to 2 and 1 to 2 will form this rectangle.
Okay.
And now in this rectangle, in fact, above this rectangle, there is this volume.
Oh.
How are my drawing skills?
It's good.
I'm just trying to, But I hope, I'm sure you followed what I'm trying to say. So we want to figure out this volume.
Okay.
That's it. And to do that, what we have to do is we simply do the integral.
Okay.
So the V is going to be double integral f of x comma y dx dy.
Is it important that is it always dx dy or it can be dy dx?
It can be dy dx as well. It really depends. It can be either ways.
Okay.
Yeah.
Okay.
So now let's quickly solve this. The volume that they're asking us to find out. Not that this diagram is so nicely done. Let's keep it. So the volume that they're asking us for is integral 1 to 2, let's say of x, integral y equals 1 to 2. Then
it's same. Okay. Doesn't matter.
Doesn't matter. Right now it doesn't matter though. Yes.
Okay. Okay.
So now we have this is what? Dy dx. Do you remember we always integrate the inner integral first?
Yes.
So we will do that. So how do we solve this now?
We will separate them.
But then the integral is going to be tricky now, this one.
Oh.
The integral is not going to be easy because we have denominator as x times y, right? The denominator x times y. The logic is pretty much the same. The idea of solving is same, but then this I'm just wondering how will we do x squared plus y squared over xy? Let me think. You can actually take x out, okay? So this one of the x you can take out for sure, so that this x can go over here. 1 over x over here.
Oh yeah.
Okay, so that's no problem. But then how do you deal with this then? Your x squared is constant anyways. This y is creating troubles.
Can it be go up like y to the minus 1?
It can go up, but then that still doesn't help, right? Equals integral x equals 1 to 2 1 over x dx, integral y equals 1 to 2. I'm just thinking what we can do. X squared plus y squared. Now this is good, but then the problem is with this y. As you said, you could take this as y inverse here. That you could do. Mm.
Yeah.
And can we then multiply? I think we can. V equals, let all this be as it is. Integral y equals 1 to 2. You're correct. So multiply this inside. So it's going to be x squared y inverse plus y dy done.
Mhm.
Tell me v equals this as it is. What is the integral of 1 over y? Ln y, right? X squared
Uh-huh.
y plus y squared over 2. I am not quite sure. Is there a ln in the answer? Let me get the hint.
Yeah, it is.
There is a ln in the answer, is it? So
It's
we're going.
3 ln 2.
So yeah, we're doing good. So let's go ahead. So let's put the upper limit and the lower limit. Please understand. Please remember that these are the limits of y.
Uh-huh.
So v equals
It's x square ln 2
yes,
plus
x square ln
2,
2
2 minus
minus
x square ln 1
x
plus
ln
1 over 2.
0, right?
Uh-huh.
Plus half. That's the low.
ln 1. 1 over 2. Mhm.
Okay, now we'll continue here. V equals the first part as it is.
Uh-huh.
Then this is x square ln 2 plus 2 minus half, isn't it?
Mhm.
So 2 minus half is 3 by 2.
Uh-huh.
V equals integral x equals 1 to 2.
Yeah.
Let's write down this part now.
Mhm.
It's 1 over x
It's like
times this, right? So
L.
I'll multiply that 1 over x to this bracket.
Okay.
Tell me, x ln 2. Do you see square 1 of the x got cancelled out?
How?
Are you getting what I'm saying?
Oh, yeah, yeah. I got it. Okay. Mhm. I see.
Just hold on for a minute.
Okay.
Here, let's write that down. Uh, Maybe later on you will otherwise struggle. Do you see
Okay.
this one was integral 1 to 2, 1 over x. I can write dx here.
Okay.
So now I'm multiplying that x to this bracket, right?
Uh-huh.
So if I do that, the x will cancel out. So I've got only x to the 1. Okay, keep going. I'll multiply that x over here. This was already 3 by 2, 3 over 2.
Yeah.
This is plus 3 over 2 over x
Mhm.
dx. So let's integrate. V equals ln 2
X
is a
square.
constant anyways. Ln 2 x squared by 2.
Uh-huh.
That's the
Yeah.
integral. Plus,
Plus.
what is the integral of 1 over x? 3 over 2 is a constant. This is ln x
Yeah.
from 1 to 2. V equals, tell me the upper limit.
ln 2.
2 ln 2.
ln 2.
2 squared is 4. 4 to the 2.
Yeah.
2 ln 2
Plus
plus
3 over 2.
ln 2
ln 2. Yeah. Minus ln 2
ln 2
over 2. Yeah. Plus 3 over 2 ln 1. It's 0. Okay.
Yeah. So V equals, can I say ln, I'll take this 2 on top here.
ln 4
ln 4.
plus ln 2. Can we write that one ln 2 to the 3 over 2?
Yes.
Okay. Mhm. Minus 1 over 2 ln 2. Oh, ln 2 to do 1 over 2.
And do you know that's 1 over 2 is just square root of 2,
Haha.
right? So let's just write that this whole thing clubbed together. That's going to be ln 4
Okay.
times 2 to the 3 over 2 divided by 2 to the 1 over 2. Do you know how it is done?
Mhm.
Do you know this? Ln A
No.
plus ln B minus ln C. Ln A is
No.
A times B, right?
Yes.
Over C. That's just the basic formula of logarithm.
Okay.
So, well, can I say V equals 4? Do you know 2 raised to 2 power 3 over 2? 3 over 2 can be written as 1 plus 1 over 2.
Mm-hmm.
So that's 2 to the power 1 plus 3 over 2.
Mm-hmm.
And then this is 2 to the half. Can I write
Is
that?
it 3 over 2 or 1 over 2?
Sorry?
Is it 2 to the 1 plus 1 over 2 or 3 over 2?
Oh, 1 over 2. Sorry. Thank you. Perfect. Corrected the right time. 1 over 2. I told you, you watch out, I make a lot of mistake. 2 raised to half
Uh-huh.
equals, this is ln 4, 2 to the power 1, 2 to the power half, 2 to
Mm-hmm.
the power half.
It's cancel out.
Cancels out. V equal to ln 8. I think it's not a correct answer. Is it a correct answer?
No, it's 3 ln 2.
Oh, that is correct.
How?
Which is equals ln 2 to the power 3.
Oh, yeah.
Thank God, finally,
Yeah.
we have the right answer. That's it. Integral
Uh-huh.
0 to
0 to
square root 3.
2 minus other one. 2 minus square root 4 minus x square. Square root 4 minus x square. X dy dx.
So now you say, how will this be?
So we just have to write x, y for the first one.
Well, let me tell you one more thing. That when I have limits in terms of x, like you see 4 minus x squared, in terms of x, they are limits of y.
Yeah.
And if they are limits of the y, then this has to be limits of x.
Yes.
And we always evaluate the inner integral first. Okay, so let me rewrite this. It is going to be I equals integral x equals 0 to square root of 3. And this is
X, y.
Can I take x out?
Oh, yeah.
Because this is the integral of y, right?
Mm-hmm.
Integral y
Yeah, it will.
to minus 4 minus x squared. Square root of 4 minus x squared. And then
Y.
x, sorry, 1 dy and dx. So we will integrate which one first? This one first?
First one.
Tell me. I equals integral x equals 0 to cube root of square root 3 x. What is this answer here? Y. It will go from 2 minus square root of 4 minus x squared.
Yes.
And square root of 4 minus x squared dx.
Yeah.
Help me. I equals, this would be integral x equals 0 to square root of 3 x upper limit minus lower limit square root of 4 minus x squared minus 2 plus, did you understand this will become plus?
Yeah.
Square root of 4 minus x squared dx. Oh, so this will not cancel out, right?
Mm-hmm.
This won't cancel out.
Yeah.
So I don't know how will we integrate this now. I equals integral 0 to square root 3. Help me.
What?
This is x times
Square root
2 times square root of 4 minus x squared.
plus
1 minute. It's all good. Plus
square root
minus
7 minus.
this 2, no?
Oh yeah.
Is that correct?
Yeah.
Dx. Then you would take 2 out.
Let's see.
And multiply by x. I equals 2 times integral 0 to square root 3 x square root of 4 minus x squared minus x dx. Did you understand this part? Yes or no?
Yeah.
I multiplied x flowed inside. Okay. So now I equals 2 integral 0 to square root of 3. This is, do you see 4 minus x squared raised to half times x dx? I'm splitting them up into 2. 0 to square root of 3 x dx. Now, do you remember in the basics, I gave you one formula which said this is f. This is n.
Oh yeah. It's f to the n plus 1
This
over n
f
plus 1.
prime. Is this f prime?
No.
So what is missing? What is f prime here is going to be?
2x.
Negative 2x.
Oh yeah, it's there.
So it's negative 2 I need here.
Yeah.
Now is this f prime?
Yeah.
Should I adjust negative half here?
Yeah.
Do you understand what I did?
Yeah, I got
There
it.
is just adjustment. Now I've got f to the n times f prime. So if I have integral f to the n f prime, the answer is f to the n plus 1 over n plus 1.
Yeah.
That's the shortcut I told you, right? So we'll use that and we'll get the answer. I equals negative 1. This here. What is the integral of this thing? F to the n plus 1. F is 4 minus x squared.
For the 1 over 2 plus 1.
3 over 2. Yeah, 1 over 2 plus 1. That's 3 over 2 divided by 3 over 2. That will go from 0 to square root of 3 minus. The other integral is very easy. It's x squared by 2. That will go 0 to square root of 3. Okay. Let's put the values now. Let's plug in the values. I equals negative 2 over 3. Do you understand this part?
Yeah.
3 over 2, I took it outside. It became 3 over negative 2 over 3. Then minus sign there. Okay, help me. Upper limit. Upper limit is going to be square root of 3. Put that here.
4 minus 3.
Yes, that's 1. 1 to the 3 over 2. Lower limit, plug in 0.
It's 0.
To the 3 over 2. 4 minus 0, right?
Yeah.
That's upper and lower. This part is sorted. Now let's go to the next one. Negative. Now there is one thing that I think we made a mistake. And you are not watching my mistakes very properly. Do you see that 2 is for the entire thing?
X.
The 2 we took out from this entire whole thing, right?
Yes.
So when we split these two, that 2 comes here and here.
And also there. Oh, yeah.
There should be 2 here as well. Is that correct now?
Yeah.
Okay, so there should be this 2. And then it will cancel out. Tell me now.
3.
3.
It's minus 0.
So you get I equals minus
2 over 3.
1 to any power is just 1. You know that's 4 to the half to the 3.
Yeah.
Minus 3.
Yes.
Do you know what that I going to be? Let me use this space.
It will be 5/3.
I negative 2 over 3. Tell me 1 minus 8.
2 to 3.
Do you see this is correct?
Yeah.
4 to the half. You know, 4 to the half is 2, right?
Yes.
Uh,
2 to 3. Yeah. Okay.
yeah, so you get this as 1 minus 8. And this side is going to be negative 3. This one.
Uh-huh.
Is that correct?
Yeah.
So you get I equals. काय होतं तुला? बाहेर नाही लिहिते रे. That's negative 2 over 3 times negative 7 minus 3. I hope we did not goof up doing anything over here. That's going to be 7 twos are 14, right? 14 over 3 minus 3. I equals 3 3s are 9. 14 minus 9 would be 5. 5 over.
Yeah. Uh-huh.
Is that a,
5/3. Yeah, it's the answer.
it's the answer?
Yeah.
High five. So we got it. Let's do 6th.
Okay.
Question number 6. It's a bit tricky. Can you read the question?
Find the volume of the region bounded by z
Z equal to something, y equals something, z equals 0, and y equals 0. Okay, you tell me.
It will be dy dx dz, right?
Yes.
Okay.
This is x, this is y, and this is z. Right?
Mm-hmm.
Do you know that there's the, look at the one is z0, right?
Yeah.
Do you know what is z0?
Yeah, it's over there. Uh-huh.
This one is z0, right?
Yeah.
Let me write its label over here. That's z equals 0. Okay.
Mm-hmm.
Z equals 0 is this plane.
Okay.
Okay. And y equals 0 is?
Mm-hmm. Right there.
This is y equals 0, right?
Yes.
That's y equals 0. So it is bounds. What are the bounds? Bounds are
Z equals 14 minus
z equals
10.
0, y equals 0. Yes. Another are z equals 40 minus
10y
and
equals
y equals.
4 minus x squared.
Okay. So now I just want you to understand, okay, that your y cannot be negative. Can it be?
No.
This cannot be, right? This side is forbidden. It's going to be ahead of this plane. This is the plane, okay? And everything on this side is what you will count.
Okay.
So nothing on the back side of this plane. The back side of this plane is going to be y 0, right? Sorry, y negative
Okay.
on the back side of this plane.
Mm-hmm.
Okay, so we're not going to take any of that. So your y is going to be always positive. Your z is always going to be positive because it's never going to be this. No,
How we know that?
because these are the bounds,
Okay.
and the bound, one of the plane, the bound is z equals 0. This plane here is one of the bounds.
Okay.
Okay, but now when you see this z equals 40 minus 10y and y equal to 4 minus x squared, you know, it's x can be negative.
Okay.
This is positive.
Mm-hmm.
But then y and z are non-negative.
Okay.
Okay, so now with that understanding, we should start solving.
Okay.
Okay, solution. Volume has to be triple integration dx, dy, dz.
Mm-hmm.
So you get v equals integration, integration, integration. Now what we can do is we can start solving this. Look, we already have limits of z from 0 to this. And these are the limits of y, are they?
Yeah.
So tell me, z equals
0 to 14 minus 10y.
and y equals
0 to 4 minus x squared.
4 minus x squared. Limits of x are not known, right? We will look at that later. As of now, let's integrate. What do we integrate first?
dz.
The inner one, the inside one?
dz, yeah.
Yeah. And then we'll do dy and then we'll do dx. Tell me, what do we get? Integral x, integral y will keep for later. What is the integral of 1?
Z.
We'll go from
0 to 14 minus 10 y.
and then dy dx is pending. Quickly tell me, how will that be? V equals integral x, integral y. We'll write that later on. This will become what?
14 minus 10y minus 0.
Dy dx. So now let's work out dy. Now this is the inner integral now.
Yeah.
Tell me, how will that work?
It's
The limits of y are from 0 to
4 minus x squared.
4 minus x squared. Okay, let's integrate.
Integral to x.
V integral x remains as it is for later.
14y
40y
minus 10y squared over 2 minus x.
That's 0, right?
Yeah, it's 0. Okay.
So you get only so much, and then the limits will go from
dx.
y equals 0.
Yeah. 0 to 4 minus x squared.
And dx is still pending.
Yeah.
Tell me, v equals
14 4 minus x squared
4 minus x squared.
minus 10. No, it's 5.
Yes, 5.
4 minus x squared to the square. Yeah,
4 minus x squared the whole square.
yeah. Minus 0 minus 0.
It's all 0. Check. 0 and 0. It's all 0, right?
Yeah.
V equals integral x. Help. 4 4s are 16. 160.
Minus 14 x squared.
Yes.
Minus
5.
12.
Let's square it. There's no other way you can do this. 16 minus 8x squared plus x to the 4 dx. So I get v equals integral x. Help.
Integral x.
160 minus 40x squared minus 16. 5s are. Can you just do the 16 times 5? 16 times 5. 80. 80.
Yeah.
Minus 8 5s are 40.
Yeah.
Plus 40x squared. That's plus, right?
Yeah.
Plus 40x squared plus 5x to the 4 dx. Okay, solving this integral is going to be a very easy part. Tell me, what will that be? Integration would be
18.
Let's just simplify this a little bit. V equals integral. The biggest power is 5x to the 4.
Yeah.
Then
18.
minus 40x squared plus 40x squared cancel. 160 minus 80 would be 80 dx. And the only catch is we don't know x.
Yeah.
So we need to know the limits of integral, right?
How?
And this is the trick part of the problem. How will you find the limits of integral? Now I want to find out the values of x, right? Do you see x can be negative or positive?
Yeah.
Where y and z cannot be negative?
Yeah.
Now I am thinking I'll find out the limits of x. What if I want to get rid of y? In this, say if I plug in y equals 0, I will get 0 equals 4 minus x squared.
2.
So you get x squared equal to 4. X equals plus or minus 2, right?
Yeah.
So the range of x is going to be from plus 2 to minus 2.
Okay.
Now you'll ask me how I get this, right?
No, I got it.
Your x is going to be from plus 2 to minus 2.
Okay.
Now you tell me why x can't be minus 3. What's wrong with that?
Why it can't be?
You see the point? Your x can't be minus 3. Tell me why.
Because the y will be negative.
Yes, perfect. So I hope you get the point. So x is going to be from negative 2 to positive 2. Now this was a trick part. Everything else was very easy. Now we can just simplify and finish this problem. Very easy. Tell me, b equals. Hey, do you also know there is one thing about the integrals, that if you have integral negative a to a of a function that is even function, then the value is 2 times 0 to a of that function.
I didn't know that.
Do you know what is an even and odd function?
Oh yeah, yeah. The even is minus fx equals
Yes.
fx.
Yes. And the odd is f of x is equal to minus of minus fx. Right?
Yeah.
So is this an even function?
Yeah.
Why? If you put x equals minus x, yes or no?
Yes.
If you put x equals minus x, this is just the same thing. Tell me how I write this now. b equals 2 times integral 0 to 2, 5x to the 4 plus 80 dx. It just makes our life easy. When you have one of the limits 0, you don't have to solve, you don't have to substitute these values so much. Anyways, this is 5 as it is, x to the 5 over 5 plus 80x from 0 to 2. Is that correct?
Yes.
5 will cancel out. b equals
Yeah.
times 2 to the 5. What is the 2 power 5? 2 power 4 is 16, 32. Plus 82s are 160.
160. Yeah.
Lower limit is 0. What is 32 and 160 sum together?
It's 192.
192 times 2. 284.
Yeah. The answer is 256.
So it means we made a mistake in solving, simplifying somewhere.
Yes.
But the approach is this. You will check later on. Shall we check now?
Can we check now?
We'll check now. I think that'll be waste of time. You know what? You can do this later on. There is.
Okay.
Yeah. So I think there is some mistake while doing somewhere here. by just cancelling out, because actually I tried this question. I have seen this question before, and this works perfectly fine. And I remember the answer is 256.
Okay.
So I'm saving it. You figure out. If you don't find something, then I'll let you know. Now, question number 7.
Yes.
How will you do question 7?
Use double integral to find area of the region.
Yes. So, do you know what will be y equals x squared minus 9?
Parabola.
Are you there?
Mm-hmm.
It's parabola, right?
Yeah.
Because when you have both x squared and y squared, it is a circle.
Oh yeah, it's x minus 3 squared. Okay.
No,
Like
that's really not x minus 3 squared, but yeah, it's a.
you can say that x squared minus 3x squared.
So can we quickly figure out how this parabola is going to look like? X and y. Let's plug in different values of x and see what happens. What if x is 3?
9. Oh, 0.
3 squared is 9. 9 minus 9 is 0.
Yeah.
The y is 0.
Yeah. Yeah. Okay.
What if x is 0?
It's 9.
Negative 9.
Mm-hmm.
You see x and y. I'm finding the values for x. I'm finding the values of y.
Mm-hmm.
Okay. What if y is 0?
It's 3 minus.
Plus or minus 3?
Uh-huh.
If y is 0, x squared is 9. And then x is plus or minus 3. Okay. So can we plot this parabola? How will this be?
Mm-hmm.
X and y. So you have 0, 3. Where is 0, 3? X 0, y 3. The first point, sorry. The first point is what? 3, 0
Yes.
is over here. Now x 0 and y negative 9. That's over here. 0, negative 9. Where is 3, 0 and negative 3, 0?
And other one you already promised.
It's over here, right? So do you see this is the parabola?
Yeah.
Can we find out the other parabola now?
Mm-hmm.
Will you help me?
Yeah. It's
Tell me
y
what is
equal.
y equals?
Yeah. 9 minus x squared.
Oh, is it? 9 minus
Oh.
x squared.
Yeah. You first one. Yeah. Yeah. It's
9 minus x squared is parabola again?
yes.
Tell me.
Just the other way.
Just the other way around, is it?
Yeah.
Let's verify. What if x is 0? Y is 9?
9.
What if x is 3?
0.
Y is 0? I think we have 3 points. I think that's good enough.
Uh-huh.
Help me plot x and y. You see 0, minus 3, 0 and plus 3, 0, these 2 points.
Uh-huh.
Yes?
Yes.
And then there's one more point, 0, 9. That's over here.
Yeah.
Do you see that's this parabola?
Yeah.
And now what is the question like? What does the question say? Region enclosed by these parabola.
Yeah.
So now let us draw a combined diagram. What if I draw a combined diagram of these two? What will that be? See?
The part inside.
So this point is 0, 9, and this point is
0,9 minus 9.
minus 9. Then this point here is minus 3, 0.
3, 0.
And this point here is 3, 0. Then one parabola goes like this. It's not a very good parabola, but you get the point.
Yeah.
And the other parabola is right. And what we want to find out is the area between these two. Right? Do you see there is absolute symmetry to this?
Yeah.
So can I say that area is equal to 4 times A?
Yes.
And let's say this is A. This is A. So you want to find out only A. Is it making sense?
Yes.
Tell me how we solve this now.
It's doubling.
Yes. The area equals 4 times double integral. Tell me the limits of x.
Limits?
X is from 0 to 3. Is that correct?
Yes.
It's only from here up till here. So x is from 0 to 3. And tell me what is the limit range of y?
0 to 9?
0 to?
9.
No. Now pay attention to what I'm saying. Do you understand why the lower end of y is here?
Yes.
But the upper end of y is the parabola, right?
Oh, yes.
The upper bound, is this a parabola?
Yes.
So,
no.
Do you see y lower is 0?
Uh-huh.
Because of this line, that's y equals 0.
Mm-hmm.
And do you see the upper end is the parabola going downward like this one?
Yes.
And this parabola has equation here.
Yeah.
Now that's the equation of this guy, right?
Oh, it's going to 9 minus x squared to x
Yes.
squared minus 9.
The equation of this parabola is 9 minus x squared.
Mm-hmm.
So the upper bound of this area, the y upper bound, is the area existing on this side here?
No.
No, right? So it's not beyond this parabola. So tell me what is the upper limit of this integral?
9 minus x squared.
And now we can solve dx dy. Tell me.
Why it's going from 0?
Because we are only taking a, right?
Uh-huh.
The reason why we are taking from a, because we know there is a symmetry and we just do 4 times.
If we do like the whole thing, it will be not 0, right?
If we take the whole thing, it will not be 0. You're correct.
Okay.
So supposing if I have to take the full thing, and not do 4 times. Now, not doing 4 times. If I take the whole thing,
Okay.
then tell me the range of x would be from -3 to 3.
And it will be x squared minus 9 to the 9
X
minus
would
x.
go from -3 to 3, and y
Yeah.
would go from the lower parabola.
X squared minus 9.
Yes. To upper parabola.
9 minus x squared. Okay.
But having these to 0 helps a lot
Okay.
while substituting the lower limits.
Okay.
This and this will give you the same answer.
Okay.
Of course. Okay, so going back to the solving, help me.
Dx dy.
Yes.
Okay. And it's 0 to 3, 4.
4.
Integral 0 to 3.
Yes. First you will evaluate y, right?
Y. Yeah. It's y.
Yes.
No.
X I can keep outside. Okay, this is y.
0 to 9 x squared.
Yes, tell me.
How you know that the first one is dy?
Because I'm integrating y.
Yeah, but y is first one.
Okay. When you're integrating and writing dy, there are limits of y.
Yeah, I know that.
Okay.
It
And
should always the first one is y.
because when you say a limit is in terms of x,
Oh, okay.
there are limits of y.
Okay.
That's how.
Okay.
Is it good now?
Yeah.
Go ahead. 4 x equals 0 to 3. 9
minus x squared minus 0.
Tell me. Area equals 4 times. Will you?
Yeah. 0 to 3. 4. 9 to 27 minus 3, minus 0.
Okay, so you get 4 times 27 minus 9. What is 27 minus 9?
18.
18 times 4.
72.
Is that correct?
Yeah.
That's the answer. Which one is the next one?
9. Find the volume under the surface.
That is above the region bounded by?
Yeah.
F of xy is x plus y. Above a region bounded by x equal to, oh, we can do this. You should be able to draw the diagram for this one though. X equals 0. What is that? YZ plane, right? Oh.
It's going that the first quadrant?
Not really the first quadrant. See, first let me write down the bounds. Okay, so volume of surface. Okay, what is the surface? F of x comma y equals x plus y, right? Above the region bounded by. So for this, we have bounds, and bounds are x equals 0, x equals y, and x equals square root of 2 minus y square. Okay, so let's just try to simplify and understand what is this all about. So you have, if I square this, What do we get?
It's x squared. Yeah,
Is circle,
parabola.
center
No.
is 0,
Yeah.
and radius is 2.
Why is that not parabola?
That radius is not 2, that's radius is root 2. Okay, I'll tell you about parabola. When there is only one of them is x squared plus y equal 2 would be parabola.
Oh, okay. Okay.
Or x plus y square equals 2 would be parabola.
Okay.
X plus y equals 2 would be a straight line.
Okay.
Yes, and x squared plus y squared equals 2 is a circle.
Okay.
Okay, so now going back, the radius is not 2, it's root 2, okay?
Okay.
Do you know the standard formula of circle?
No.
The standard formula of circle is x squared plus y squared equal to r squared.
Mm-hmm.
And that's a standard circle. And that circle has got a center origin.
Mm-hmm.
And the radius is r.
Okay.
And that's why r is root 2.
Okay.
Okay. So once you get that, r equals square root of 2. What is this y equals x? Straight line.
Uh-huh.
And what is x equals 0?
Point.
YZ plane.
Mm-hmm.
So let me try and draw a diagram just to visualize this whole thing. Okay.
Mm-hmm.
This is x. This is z, YZ. I'm just thinking which way it will look nice. Let's take this as z and let's take this as y. Okay. So x equals 0 is yz. Yz would be here. That's yz, right? Now, what is going to be x equals y?
Straight line.
45-degree line.
Mm-hmm.
That makes a 45-degree angle with x-axis. That's that. Okay. And what is x square plus y square equals to?
Circle.
Circle in xy plane, right?
Mm-hmm.
So that circle is over here. Right?
Yeah.
Now you tell me what are the bounds? Look, one of the bound is this plane.
Mm-hmm.
The equation of this plane is x equals 0. The other bound is this line, right?
Yes.
And the next bound is this circle. So do you understand it is this circle and this line?
Mm-hmm.
Can you imagine a slice of a pizza over here?
Yeah.
And so let to draw the diagram more nicely. This is x, this is y, and that is the slice of the pizza,
Mm-hmm.
which is the bound.
Okay.
So you have this as a z-axis. You have this as a z-axis. And now f of x comma y is nothing but x plus y. So that is the surface over this pizza.
Okay.
Now, this surface could be any surface. But then it is strictly over this pizza slice.
Mm-hmm.
And we want to find out this V.
Okay.
My internet is unstable. We want to find out this V. Oh, I hope you followed what we're trying to do.
Yeah, it's hard to see, but I got it.
Okay. So how will we do that? Volume bounded by the surface, like how we did before, right?
Mm-hmm.
How will we take these bounds? And we have done a similar question, but that was much easier, right?
Yeah.
Tell me, the volume is going to be triple integration
Mm-hmm.
dx, dy, dz. Do we know the bounds of x for sure?
Yeah.
What are the bounds of x? X equals y and x equals this, right?
Yeah.
So I think we can make a use of that. X we already know. X.
X equals Y, so we know Y also.
No. We only know the bounds of x equals y. X equals y is this line.
Okay.
And we know, now we have three values in terms of x.
Mm-hmm.
How do we make use of x equals 0 then? We are very close actually. And then we know this is one of the bound. And then we know this as a bound.
Mm-hmm.
That's a circle, right?
Yeah.
How do we incorporate all of that? X square plus y square equals 2 is a circle.
Mm-hmm.
And do we know the height of z? Oh, we know z also. Okay. So, this question cannot be solved with the bounds of x and y. Now I have to teach you something else over here. Pay attention.
Mm-hmm.
Uh, Pay good attention, okay?
Okay.
And the idea is here. Have you heard of polar and rectangular?
Yes.
Rectangular and polar. Rectangular is when we talk in terms of x and y,
Mm-hmm.
and polar is when we talk in terms of r and theta.
Okay.
They never coexist. Either it is r theta, or it is xy.
Okay.
So what we're going to do here is we're going to convert our xy into r and theta now.
Mm-hmm.
And the conversion is x equals r cos theta. That's the relation between the two.
Mm-hmm.
Y equals r sin theta.
Yeah.
And dx dy equals r dr d theta.
Okay.
And I think this will come to a rescue right now.
Mm-hmm.
So I'll tell you why. Because do you see, when I say theta, theta is always angle with the x-axis.
Mm-hmm.
Tell me, what is theta here?
Theta mark.
45 degrees, right?
Uh-huh.
You see that? I already wrote it here.
Yeah.
It's a 45-degree line to x-axis. Okay, do you know this is x-axis, this is y-axis, and this angle is 45 degrees when you say y equals x.
Okay.
That's what it is over here. So I know this angle is 45 degrees. Is it understood?
Yeah.
Okay. Now going back, this theta is pi over 4. So this is the starting, right?
Mm-hmm.
What is the highest value of theta you can get?
90.
Yes. So theta in our case, in our situation, theta is going from pi over 4 to pi over 2.
Okay.
This is pi over 2. We always measure angles with respect to positive x.
Mm-hmm.
And I already told you that this is going to be our base.
Okay.
And on top of this base, you have this surface.
Okay.
And the range of base is going to be from here to here.
Uh-huh.
Do you agree?
Yeah.
This is how theta is, right? Now we're going to talk about r. Are you there?
Yeah.
Is it understood so far, or you want a quick recap?
I understood.
You understood. Okay. So now for r, now first of all, you understand what is r and what is theta. What is theta? Angle with positive x axis. Say that again.
Angle with positive axis. X-axis.
Do you know what is r?
Angle with y-axis?
Positive. No, no, no. It is distance from origin.
Oh.
R
Oh yeah.
is distance from origin. It's polar form, right?
Mm-hmm.
So now you tell me that for this pizza slice, I'm talking about this pizza slice over here. This one. This one. You tell me this is x-axis and this is y-axis.
Uh-huh.
You tell me what is the lowest value of r can be. Remember, r is distance from origin.
0.
What is the highest value of r can be?
0.
No, root 2.
Root 2. How? Oh, it's r. Okay. Okay. I got it.
You got it?
Yeah.
So
It's
the
equal
lowest
to
value of r is 0 and the highest value of r is root 2. It cannot be more than that.
Okay.
Because this circle here has a radius root 2.
Okay.
That's why. So like I said, the theta is going to be from pi by 4 to pi by 2 and not less than that or not more than that, not beyond that.
Okay.
R will be from 0 to root 2.
Okay.
So you have got R going from 0 to square root of 2.
Mm-hmm.
So now I have found the limits of theta. I have found the limit of R as well. Now, do you see that here? What is the value of dx dy?
R d theta.
So I'll write this as R dr d theta. Look, this part is sorted. The only thing that I don't know is dz. So I'll worry about that later.
Mm-hmm.
Okay. Should I clear this or do you want me to revise and explain again?
Can you explain one more time?
Yeah, I think so. So look, first of all, let me save. Okay. So I have saved it, so don't worry. Okay, so tell me what are our bounds right now? X equals 0.
Yeah.
This and this are our bounds, right?
Mm-hmm.
One bound is YZ plane. One bound is this straight line y equals x.
Mm-hmm.
And one bound is a circle with a center 0, 0 and radius is square root 2. Yes or no?
Yes.
Okay. So how do they look like on a plane? This is x, this is y, and this is z. X equals 0 is this plane.
Mm-hmm.
X equals 0 is this plane. Is it very clear?
Yeah.
And then x squared plus y squared equal to 2 is a circle with the center 0, 0 and radius is square root of 2.
Okay.
And that circle sits here. Please understand this circle is on this plane,
Okay.
on this xy plane. Okay, it's part of this plane, xy plane. All right, so let this go. And then x equals y is a 45-degree line. So whatever we say, the surface is going to be bounded by this plane. So the surface is not going to be on this side of the plane, it's going to be on this side of the plane.
Okay.
The other thing that is binding it is this circle. Can you look at my face? Look. So let me explain. Yeah. You have x, y, and z, 3 axes. Then let's just say this is xy. Okay. So all the action is happening on xy. Okay. Okay. YZ is this x equal to 0 plane. So nothing is going to be on this side. This is that plane x equals 0. Okay. So nothing is on this side. It's all going to be on the other side. Okay. Now on this side here, ahead of this plane, there is one 45-degree line in between the two. And then there is a pizza shape. Now this is not helping, is it? No. Come back to the diagram again. So now this is the pizza shape that is our bound. Okay. And in that bound, on that bound, like x, y, and we figured out the bound is here, made by one circle, made by this line, and made by this plane. So we say that on top of this, there is one surface over here. Inside this pizza shape. Now that's the pizza slice. On top of that pizza slice, there is a surface here. I don't know what shape of that surface is. Okay. And that surface and this bound, we want to find out the volume here. Okay. Is the task. Now I am saying that when you want to find volume like that, trust me, your regular rectangular form won't work well. Okay. Instead, you go for polar form where we don't write xy, we write rather r theta. Okay. Where theta is the angle with a positive x-axis and r is the distance from origin. Can you repeat that? Theta is the
x.
Theta is the angle with positive x. Yeah. And r is the
distance from origin.
Distance from origin. Now, talking about this region of ours, you please tell me, theta can be minimum 45 or maximum pi by 2, because that's what surface we're talking about right now. We're talking about this bound right now. Is your pizza slice on this side?
No.
Why? Because we already said, na, x equal to 0 is a bound. So it's not going to be on this side. It's not going to be on this side. Why?
Yeah.
Because this line is also your bound, which is x equal to y. So it's neither this nor that. So it has to be between what and what?
Pi over 4.
Pi over 4 to pi over 2. Does this integral make sense?
Yes.
And the limits of theta?
Yeah.
Okay, so theta is sorted. Now let's think about r. Tell me, are you worried about this distance here? Are you worried about this side? Are you worried about this part?
No.
Why? Because you know that it's inside this circle only.
Uh-huh.
Because that's what it is said here. Bounds is this circle also.
Yes.
And being the bound being circle, it can't be here. This can't be.
Mm-hmm.
So what is R? Read here. Read.
Well, it's R. It's the from origin.
Distance from origin, right? Yes.
Yeah. We are
So
looking for.
tell me, can your distance from origin be so much?
It's from no.
No, right? Because now this point is too far.
Mm-hmm.
What will be the distance from origin? Root 2 max.
That
Do you get it?
its distance is R. Yeah. It's
R can be only root square root of 2.
yeah.
And the lowest the distance will be is 0.
Zero.
Is this point going to have distance between 0 and root 2? Yes.
Yeah.
Are you getting the limits of R, why they are 0 to square root of 2?
Yeah.
And then do you understand that we are not using xy, we're using r theta?
Uh-huh.
So we are writing dx dy as r dr d theta.
Yeah.
So let's not get into why right now because it will divert the topic completely.
Okay.
So let's just assume that dx dy is going to be r dr d theta.
Uh-huh.
So the only limits we don't know are the limits of z, but everything else is figured out.
Okay.
Right? So now, once you do that, next is let's solve this more. Okay, I'm going to erase this again. And I think we don't need this also. We already have the neat diagram that I've drawn before this. So it's all saved. Okay, going back to the question now. Let's solve this. Will you remember this? I think I will. Okay, so tell me, okay, what was V? V was initially integration, triple integration, dx, dy, dz, right? So this was z, this was xy. So xy is converted into polar. This was what form? Rectangle?
With dy.
Yeah. I mean, yeah. I'm not worried so much about it right now. Okay. Now tell me about V. Integral Z will keep for later.
Mm-hmm.
Tell me, the range of theta was what? Pi over 4.
Pi over 2.
And the range of R was? Lowest was 0. The highest was square root of 2. Then dx dy was R dr d theta.
Mm-hmm.
And dz stays as it is. So first we'll integrate this. Tell me, V equals integral Z,
Pi over
integral
2.
theta,
4.
pi over 4 to pi over 2, r squared by 2,
0 to
square root of 2, d theta, dz.
R.
Tell me now.
And R.
V equals 1 over 2. That half, the 2 I'll take it out.
Mm-hmm.
Integral Z,
Pi over 4 to pi over 2.
theta goes pi over 4 to pi over 2, 2 minus 0.
Yeah.
Is that correct?
Yes.
D theta, dz. Tell me, V equals 1 over 2, integral Z. Oh, I'll cancel out 2 now. This 2 is a constant, right?
Yeah.
We'll cancel out this. What is the integral of 1 d theta?
D theta.
We'll go from pi over 4 to pi over 2
Pi over 2.
dz. Now what do I get? Tell me. V equals integral z
Pi, theta to
pi over 2 minus pi over 4 dz. You can always tell me to slow down or speed up.
pi over 4.
Pi over 4 dz. V equals pi over 4 integral z dz. Now the only thing that we don't know are the limits of z.
Yes.
How do we find them?
I don't know.
Have you followed this so far?
Yeah.
X and Y and the pizza slice is your base. This is one of your bound for sure. This is one of your bound for sure. And then you're talking about the surface which is on top of this.
Okay.
This surface. Now the only thing is how much is your Z? Is there anything said about this? Do you realize that Z, the lower limit of Z is 0?
Yes.
Is lower limit of Z 0?
Yeah.
Why?
It's from origin.
Let's you to read the question again. Find the volume surface under above the region bounded by. Do you see above the region bounded by?
What's that mean?
There is a sentence that says above the region bounded by these things.
Okay.
So the lower end of Z is 0. So I'm very sure that Z lower is 0.
It is 0 because they say the above the region.
Yes. Look above the region. What is this plane? Which plane is this? XY plane, right?
Yeah.
And when I say XY plane, this plane has got Z 0, right?
Yeah.
When I say XY plane, do you remember the first initial basis that I gave you? XY plane has got a Z 0.
I can't hear you.
Sorry? Excuse me. Hello? Are you there?
Hello?
Yes, I can hear you properly. Can you hear me?
Yeah.
Oh,
Oh, I can.
yes. Okay. So, when it says above Z equals 0, that is XY plane has got Z 0, right?
Okay.
So, Z 0 is the lower end. Now, we have to just figure out what is the upper end of this thing. But then there is absolutely no upper bound given, right? So we're very close actually. Volume of surface bounded by volume of, find the volume under surface, f of xy equal to x plus y. That is above region bounded by. What is the answer to this one? 2 square root t 2 over 3.
Yeah.
There is no pi as well, right? The surface which is above region bounded. f of x comma y is x plus y. I think there is some data missing on the question number 9.
I can ask the teacher.
Please.
Okay.
Because the z lower is correct, the z upper you will not be able to find out unless they tell you that.
Okay.
So that's that. So we actually covered conversion of polar form as well. Yes. Tell me question number 10. Super easy.
Use polar coordinates to evaluate
Okay.
double integral.
Integral over r e to
E.
the x squared plus y squared. dA is dx dy or dy dx, right?
Uh-huh.
Whereas r is a region in the first octant between circle of radius 1 and radius 2, both centered at origin. The first octant, right? So we'll take this. This is x and this is y. And then there are two circles. One circle is here, and other circle is here. The first one has radius 1,
Mm-hmm.
and the second one has radius 2.
Yeah.
And convert to polar form, right?
Yeah.
It is I. Between circle of radius 1 and radius 2. Do you understand? This is the area.
The first one is 0 to 1.
Sorry.
0 to 1. No.
No. No, 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 no. You tell me what is going to be theta?
Theta.
The theta 0
Uh-huh.
to 2 pi, right?
Oh. Yeah.
So
Yeah.
theta will be from 0 to 2 pi.
Uh-huh. R will be 0 to 2.
1 to 2.
1 to 2. Oh, yeah. Yeah. Okay.
You get it?
Yeah, I get it.
So then the next will be e to the r squared. Do you know why? X
Uh-huh.
equals r cos theta.
Yeah.
Y equals r. These are just the standard relations.
R square cos square theta.
So if I square and add, if
Okay.
I say x squared plus y squared, that's just r squared times 1.
Oh, yeah. Okay.
So
I
that's
have
how
to.
I get this as r squared.
Okay.
And then dx dy is just r
R d R d theta.
d theta.
That one
Now,
is real.
first we'll solve this part.
Okay.
Therefore, we get I equals theta equals 0 to 2 pi. Yes. How will we solve this?
It's same.
Nope.
2.
Nope. You have to put r square equals t. And then differentiate. Do you know how that's done?
Differentiate.
Yes. So you get 2r dr equals dt.
Mm-hmm.
Then r dr equal to dt over 2.
Yeah.
And then change of limits. When r goes from 1 to 2, t will go from
1 to 2.
1 to 4. Why?
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 Oh, 2 square.
Yeah, r1, then t is 1 over
Okay.
here. When r is 2, the t is 4.
Okay.
So now with this replacement, what will be your integral? This will be integral t equals 1 to 4 e to the t. Are you with me?
R. Yeah.
Yes. Then what is
R.
r dr going to be?
t dt dθ.
R dr would be
dt over 2.
dt over 2. So I'll write that as I equals 1 over 2 out. Theta goes from 0 to 2 pi. What is the integral of e to the t?
e to the t.
That will go from 1 to 4. D theta is still remaining outside.
Mhm.
Tell me. I equals 1 half. Integral theta equals
V2.
0 to 4. E to the 4 minus e d theta. What do we get now? I equals half. Help. E to
How
the
much?
4 minus.
4.
These are limits of t, right?
It's take. Yeah, it's 0 to 2 pi, not the 4.
I'm sorry, 0 to 2 pi. Okay. So is this whole thing constant?
Uh-huh.
So I took that out of integral.
Yeah,
So you'll get theta equals 0 to 2 pi,
theta.
1 d theta.
Mhm.
So what do you get?
1
Half
over e to
e to
the
the
4.
4 minus e. Theta will go from 0 to 2 pi.
Yeah.
I equals half e to the 4 minus e, 2 pi minus 0. And 2 cancels out.
It will be 4 pi over 4.
E to the 3 minus 1 pi.